So in this video we are going to discuss about another very important concept from data structures and algorithm, that is an introduction to asymptotic notation, big O notation. A notation used to describe the algorithm's running time is called asymptotic notation. Definition: a function f of n is said to be order of g of n if there exist positive constants c and n naught such that f of n is less than or equal to product of c and g of n for every n greater than or equal to the n naught. Here this g of n, it is an arbitrary function, and of course c is a constant. So the product of these two, it should always greater than the value of this f of n. There are two rules we are following in order to simplify the big O notation. That is, one is we have to drop the lower order terms. The second one, drop the constant multipliers. For example, let us consider we got a value that is order of 4n. This can be written as order of n. So it is a linear function. So in which just we have dropped this number 4, that is constant multiplier. Another one, order of 4n square, in which you drop this 4 and consider only this the high order value, that is n square. So here also we drop this constant multiplier. So it is a quadratic function. Similarly, order of n plus 1000 is equal to order of n only. We drop this lower order term. Similarly, order of 2n square plus n, it is order of n square. We are dropping the value, that is the low order terms, as well as this constant, that is 2. So it is nothing but a quadratic function. Similarly, order of 2n plus 400 plus n cube plus n square. So here just simply we will remove all these low order values. So this 2n, 400, then n square, everything will be, that is eliminated, and we will consider the higher order value, that is n cube. So it is a cubic function. So this is how we can simplify this the big O notations. The classification of algorithm based on the big O notation. For example, the constant time algorithm, it is nothing but order of 1. Similarly, the logarithmic time algorithm, it is order of log n. Then linear time, it is order of n. Polynomial or quadratic algorithm, it is order of n power k. Next one is exponential algorithm, in which there is order of k power n. So we should know the complexity of the well-known algorithms. Mostly in some of the interviews this kind of questions are asked, like what is the complexity of the linear search. So it is order of n. Similarly, the complexity of the binary search, it is order of log n. Bubble sort, it is order of n square. Similarly, for med sort, it is order of n log n. So these are the complexity of the well-known algorithms. Next I move on to the rate of growth of the algorithm. The complexity f of n of an algorithm, that is m, it increases as the size of the input data n increases. So if the size of the input increases, so naturally the complexity is also increases. See, for example, if you consider a loop, if the loop is executed for one time, it will be considered as one statement. If the loop is executed for 100 times, then it will be considered as 100 statements. If the n value increases, and naturally this the number of statements increases. So in that way, if the number of the input size increases, again the complexity of the algorithm will also increases. So the order of this complexity is given here. This order is the order of 1 less than or equal to order of log n less than or equal to order of n less than or equal to n log n, then order of n square, order of n cube, etc., and reaching order of 2 power n. See here just a table is given here in order to understand how actually this the rate of growth of algorithm increases depends upon the number of inputs. See, for example, this is arbitrary function, that is g of n. Here we are giving this input values. For example, if n value it is 5, so what will happen? Log n is 3, n is 5, and this is 15, 25, 125 and 32. Similarly, if this g of n is 10 and here this log n value it is 4, n is 10, this is n log n 40, n power 2, that is n square is 100, this is that is 10 power cube, and this is also 10 power cube. Similarly, if it is 100, this is 700, this is 700, 10 power 4, 10 power 6, and this is 10 power 30. Similarly, if the value of this g of n increases, that is 1000, so the log n value it is 10, but n value it is 10 power 3, that is 1000. This is n log n, this is 10 power 4, and this is 10 power 6, this is 10 power 9, and see the last one, this is 10 power 300. See, once if the value of this input, the size of the input is increases, so naturally the complexity is also that is increases. So that is what actually I want to prove with the help of this table. So in this video we have discussed what is the asymptotic notation and what are the rules regarding that, and some of the examples we have discussed, and similarly the classification of algorithm based on this big O notation, and also we discussed some of the complexity of well-known algorithm, and finally the rate of growth of algorithm with the help of this table. I hope you understood the concept. Thank you. Keep watching.